Hello everyone, welcome back to Soft Embedded Insight. In today's video, we are going to learn very simple and important concept in embedded system, how to connect to switch to an STM32 microcontroller and control LED based on it. So firstly, we will understand why pull-up register is important here. So let's keep it's even simple when let's assume there is no pull-up register and it connect no pull-up register connected. So microcontroller can get random value, either 0 or 1. It's undefined. Like when we press switch, it's get 0, but when there is no press switch, it get random value. So microcontroller can't decide what to do. So now here we added a simple pull-up register. Now the pin will stay high, and when switch is not pressed, that time pin stay high, and when you press the switch, the pin connect when you press the switch, it's connected to the ground, so we get a 0, and it's simple and very reliable thing. So that is very important thing to add a pull-up register. But now here is a good thing in STM32. We don't need to connect physical register because the microcontroller itself has an internal pull-up option, so which can enable using STM32 CubeMX. Okay, but as a beginner, we have aware of that. Okay, okay. Now let's see the Proteus simulation. So I have added STM32 microcontrollers, connected switch via pull-up register to the GPIO pin 3 and connected LED to the GPIO A pin 8. So it's like that. And if you don't know how to configure the power supply setting for the STM32 in a Proteus, check out my previous video where I explain Proteus power configuration for the STM32 simulation. Now, let's jump into the code using STM32 CubeID. Create project, new STM32 project, select our board. Okay, let's make it is a here we connected LED, so it's as a GPIO output and PA3 GPIO input. Mm. Firstly, inside our while loop, uh, we will declare a variable called SW to store the value of our switch pin. This variable store the either 0 or 1 depend upon the switch state. Now we will read the GPIO pin where we connected switch. So switch HL GPIO. GPIO A and pin number 3. This read the current logic level of the GPIO A pin 3 and it store the variable in SW. Then we will use a simple if else statement to control LED on a PA. If SW is equals 0 means when switch is pressed, HL GPIO, right? So we have shortcut control and press space bar GPIO A and pin A, and pin state is a 1. That means high. In else means like it's a default conditions, like when when we don't press a switch that time, what we do, so we have to just make it as a low. Just copy and paste and just 0. If the switch is a 0, if the switch is 0, that means switch is press and then turn LED on, and else turn it off. Okay, now just complete the project. Create hex file, properties. Hex file is created successfully. Now add hex file to our Proteus simulation. Click on switch, debug. Now here, when switch is not pressed, that time microcontroller read as a high. And now here we are space when switch is pressed, so it's read as a 0. Now LED is turn on, turn on. If you like this simple explanation, don't forget to like, share, and subscribe to my channel. Stop Embedded Insight for more embedded system tutorials.